All right, welcome to Module 8 and Arrays. So we're going to start talking about arrays. All right, so far we have these different data types. We have int, and we have double, and we have char. So when you declare an int or a double or a char, you get a piece of memory. For example, we would get a little piece of memory here. Say we say int num. You get a little piece of memory right here called num, and num has a location, address of num. Now if we declare an integer pointer, and this is the same for double or character, but if we were to declare an integer pointer, we would do int nptr, and as we've already learned, nptr would point nowhere unless we said nptr equals address of num. So that would take this pointer that was pointing there and point to that same location. So usually when you declare a pointer, you don't get a piece of memory. Now let's also assign this a value just to make it num equals 10, so we can put a value in here. So there's a 10. All right, so that's an equal sign over here. So usually when you do this, what happens is if you declare a pointer, your pointer has to point somewhere. And you don't get assigned a piece of memory with data for your program when you do it that way. So that's why we've only used pointers by passing by reference to arguments. But there's another way to declare a pointer, and that is to declare a whole series of items. Let's have a little motivation here. What if I had 10 students in my class and I wanted to store all 10 IDs? Well, the way that we would do it now, I would say int ID 1, ID 2, ID 3, etc., etc., etc. So what would happen is I would have to declare 10 integer variables in order to store 10 integers in order to store 10 items that are similar. Well, now you can declare a pointer, and a pointer to a bunch of elements in memory that are consecutive. Now it has to match. If you're doing an integer, you have to do a bunch of integers. If you're doing doubles, you have to do a bunch of doubles. And if you're doing characters, you have to do a bunch of characters. So first you need to do is decide how many you want. So I want to store 10 IDs. So I declare my data type is int. The name of my variable, my array, this is called an array, is called ID. And I put in square brackets how many that I want. So what I get here is I do get a pointer called ID that's going to point to a location in memory, and it's going to point to 10 consecutive IDs in memory. And this is going to be ID at index 0, and this will be ID at index 1, and this will be ID at index 2. And if you can't read what I'm writing, those are just square brackets. And this would go all the way up 3, 4, 5, 6, 7, 8, 9 to ID at index 9. This is called an array, and it's very good for storing data, because if you have a bunch of information and it's very similar, rather than have to have a separate variable for each one, you can now get a whole series of information. And so just to make this, ID is an integer pointer, and ID at any index within the range of 0 through 10, 0 through 9, is an integer. So ID at index 4, for example, the data type of that is int, or integer. All right, so what if I wanted to put some data in my array? Well, one way I could do it is I could say ID at index 0 equals 454. So that would go to ID at index 0 and put a 454 there. Anything that I can do with an integer, I can do with ID at any location. So I could say ID at index 4 equals 26. So it would go to ID at index 4, so this is 3 and this is 4, and put a 26 there. I could do math to it. I could say ID at index 5 equals ID at index 4 plus 10. So what that would do, it would go to ID at index 4, take that 26, that would be a 26, add 10 to that, and assign that result to ID at index 5, which would be a 36. So I'm still just like assigning one at a time, and that's perfectly fine. But another way to do it, I'm going to go to the next slide, is you can declare and initialize all the values at once. So I could say int is my data type, ID is the name of my array, and I have 10 cells, and I want to initialize them to numbers. So the way that I do that is I use curly braces. So I say I want to use 35, 24, and 16. All right, so I did something a little different here just to show you what would happen. So what would happen is, and the way you draw arrays, even though it is a memory, you don't really draw it like a memory map. They get drawn like this, and you're going to want to learn to draw them like this because soon we're going to be using character arrays, and when we start character arrays, you're going to start making words, and that's how we read words. So this is ID, and this is 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. So this is ID at index 0, and this is going to be ID at index 1, and this is ID at index 2, and this is ID at index 3, and so on. This is 4, 5, 6, 7, 8, and 9. And those should all be, to be integers, you have to put ID within the brackets. All right, so now what I've done here is I've said I want to start from the first cell and put a 35 there, and the next cell and put a 24 there, and the next one and put a 16 there. So the rest of them I don't know what they are. So if I try to say printf %d ID at index 6, which is this one right here, ID at index 6, that's the integer variable, what do you think would happen? Well, you should type this up and give it a try and see what happens. What would happen is the same thing as if I said int x, like if I declared int x like this and did not assign it any value and then try to print it. So if I only assign the first 3, it's going to go in order and fill in the values into the first 3. Now I can, if I have 10 elements in my array, I could go ahead and declare and initialize those 10 elements in my array in order. I ran out of room, and I wanted to, usually students want to know what happens if you don't. All right, so let's move on. All right, so let's talk a little bit more about how, let's use a different data type. So let's use the data type of doubles. So I'm going to declare an array of doubles called scores. I'm going to make it size 4. So I'm going to draw my picture down here. This is scores. That's the name of my array. This is scores at index 0, scores at index 1, scores at index 2, and scores at index 3. I did not draw it to scale, but you can still get the idea. Now if I assign values, one thing you can do, and you can only do it with the 0, is you can put one single 0, and that's going to put 0 in every single one. It only works with 0. It doesn't work with 1 or 2 or anything else, so don't try to do that. The only other way you can assign values is you can declare it, and I could say, let's get a double nums size 5, and equals 35.6, 21.2, 14.8, 3.0, and 1.0. So what that would do is it would create an array called nums. And the reason I do this, because that's where it points. It has an index 0, which would have a 35.6, an index 1, which has a 21.2, an index 2 with a 14.8, an index 3 with a 3.0, and an index 4 with a 1.0. And it's very common to get confused and forget that if I have 5 elements in my array, that goes 0, 1, 2, 3, 4. If I have 4 elements in my array, 0, 1, 2, 3. All right, so let's look at a neat slide now, which is typed up, and talk a little bit more about arrays. All right, so with arrays, array is a data structure. That just means that it stores data and all under one name. So this is going to be, the name of this is called X. And so all the data has to be homogeneous, or in other words, the same type of data. You cannot mix integers and arrays. And at this time, we are only familiar with integers, doubles, and characters. So if you wanted to store an array of characters or an array of doubles or an array of integers, and even if they were related, you would need 3 separate arrays. You need to have an array of integers. It can only store integers. An array of doubles can only store doubles. An array of characters can only store characters. So there's a subscript that goes into square brackets, which indicates which element. So this is the way you read this. This is a double array called X that has 8 elements in it. And the first element is going to be at subscript 0, 1, 2, 3, 4, 5, 6, 7. And X is actually a pointer that points to the first location in the array. All right, so keep in mind, X is a double pointer. X at any index within the array is a double. So anything that I can do with a double, I can do with any of these elements in my array. I can printf with %f. I can scanf into it with %lf. I can do math. I can pass it to a function whose argument is a double. This right here, X at any one of these subscripts is a double. So it's just like I said, double X. It's going to do the exact same thing. Now, what about X at index 8? What about the variable X? What happens at X at index 8? Well, I don't know if that's a double, because when I declared my array, I said I wanted 8 consecutive cells, and so I only get 0 through 7. So whatever is stored right here in memory, I have no idea, and it is not part of my array. So it's very important to keep track of your array. That's why you want to practice drawing pictures. All right, so let's talk a little bit about character arrays. Character arrays are just like double arrays, only character arrays end with what's called a null character. And the null character is a weird character because it has two different characters, a backslash and the number 0 between single quotations. But it's treated as if it was one character. So we will be spending much more time on strings and character arrays. We have a whole bunch of lessons on that, and videos and assignments and practice. All right, so let's just talk a little bit more about, this is what I just said. Anything that you can do with a double, you can do with X at one of these subscripts. So if you can print it to the screen using %f, that's a 0.1, not an L, %1f, then that'll print to the screen because that's a double. You can assign a value to it, you can do math with it, you can do anything that you want that you can do with a double, you can do once you have declared your array and given it a size, and then any of these items within the array are treated just like doubles. And if it was an integer array, it would be the same thing. So let's just talk a little bit about this magical loop, this for loop that we are going to be using throughout the semester to access our arrays. So this is the for loop. All right, one thing is this pound define size. This is just defines it allows you to use this word size instead of in place of the number 11, which we used that in one of our programming assignments. So don't get thrown off by that. And so if you have an array, so what happens here is I have an array. The name of the array is square. The size of it is 11. And I'm going to add up all of the elements in that array and store it in a variable called sum. Now this is the magical loop right here that you want to remember. This loop is going to go from the first element in the array throughout all of the other elements in the array. So let's just take a look at it, and then in the next video we will talk more about it. So this is an array. So you say for I equals 0, this is going to be at the name of the array is square. So this is square at index 0, square at index 1, square at index 2, etc. up to 10. So this loop is going to go for I equals 0. It's going to start at the first location in the array and go up by 1 every time. So it'll start at 1, at 0, then it will go up to 1, then it'll go up to 2, then it'll go up to 3, then it'll go up to 4. And what this does the same thing as I++. It just adds 1 to I and checks. And if this is an 11, so when it reaches 11, which is out here, and is no longer, that becomes 11 is less than 11 is not true. This is the number 11. Then you have passed the outside of the array. So in the next video, we're going to review a little bit about arrays and then start talking about the loop to go through an array.